I suppose we can start. You can hear me, right, like this, or?
Hello?
Whoa. Okay. Hello all. Suppose it has been an interesting couple of days for all of you. I think we can start. I'm Nikos Ntemkas. I work as an API engineer in Vodafone. And some questions. How many of you are you working with microservices? And very nice. And how many of you maybe have created your own operators, Kubernetes operators? Very nice. And maybe created your own custom resources definition inside Kubernetes? Well, today we're going to talk about all of these things and how we use them to modernize our core IT systems. Now, I'd like to start with why we need to do this, and the answer actually lies in the picture on its own. It's huge, and it should be huge because Vodafone is like major telco, but the problem lies in the fact that each one of these tiny boxes that you see here, and you can't read what it says, is a big monolith. It's a scary word, right? And since Vodafone has a lot of history, most likely you will encounter inside each of these monoliths some legacy code. And this, as you know, introduces delays, and in a landscape where response demand is near real time, this is a big no-no, right? And we count in them, there are more than 150 systems. So we need to modernize it, right? We need to modernize IT. And the question transforms to how? And how do you begin to transform something of this magnitude and this criticality as well? Well, for us, the answer began with finding a very cool name. No, but we have it's called C.E.L.L. It stands for Componentized Enterprise Logical Layer. And the answer for us started with the architecture. We had to know where to build the blueprint we had to follow to build C.E.L.L. And our research led us to the TMForum. Now, we're not going to talk about TMForum. This is a beast on its own. It starts for telecommunications forum. I'm mentioning it because first in Vodafone we are TMF API compliant. We use TMF APIs in our microservices. And most importantly, at least for this presentation, is the ODA architecture blueprint. This is where C.E.L.L. is built upon, what C.E.L.L. is built upon. And Vodafone is one of the first adopters, I would say, for the ODA architecture. And for those of you who might be discouraged, perhaps, because of the telecommunication part in the TMForum, I would like to ease your mind. The core ideas and core concepts of the ODA architecture is applicable to all clusters, and is not only if you are a telco provider. Now, what is C.E.L.L.? C.E.L.L. is a microservices cluster with one big goal, a motto, if you'd like, and this is to decouple. Decouple release processes between teams, so you no longer get tangled between what one is developing and what you are expecting from the other team, and to decouple infrastructure concerns from software. So when you create a microservice and you deploy it, you no longer have to consider stuff like, oh, how I'm going to configure the Kafka, or how I'm going to expose it in the gateway, and stuff like this. And of course, this removes bottlenecks from across all teams, SAs, DevOps, because no one has to think about this stuff anymore. Now, this is a bird's view of our cluster. We use a lot of modern technologies, as you can see here, and a lot of new ones are being considered as our needs expand. What I would like to emphasize for these few slides is the fact that we use Java and Quarkus not only to develop microservices, but also to develop our own custom Kubernetes operators. More on this later. But for now, since I mentioned that C.E.L.L. wants to decouple, right? What do I mean with this? Here we have two ways of developing microservices, right? The left one is more or less the traditional one, where you have the right one. the traditional one, where you have teams working on microservices, and inevitably, some of them will become more used like the others, somewhat like core, but not exactly core. And then you get into situations like, okay, team A is developing a feature, right? And team B wants that feature. And then something happens in team A, and this has to be postponed. Now team B has to wait, right? And this creates a whole big of a mess. Jira tasks left in the board, POs left unsatisfied, product managers, creating pressure. No one wants this, right? We would not like this. So this is what the OD architecture proposes and what C.E.L.L is doing. And what we do is to bundle all microservices that work together to expose a single API in a package. This package is called Oda Component. And what this allows us is to, for the rare cases that some microservices, like some utility microservices, need to be reused, like think of a mapping microservice or a scheduling microservice or something like this. Well, instead of waiting, why don't just you develop your feature on yourself, include it in your package, and then deploy it? Of course, this will introduce some kind of redundancy, but the trade-off for the speed you get in the release process and the smooth out of the release process is more than worth it. Okay. And now I mentioned ODA component. ODA component is part of the ODA Canvas specification, of course. And what it is a collection of microservices that work together to expose a single API, as I mentioned before. And I don't know how you would approach, deploying a lot of microservices together. We use Helm charts. It's, I think, the best way at this point. And what differentiates an ODA component from any other component, from any other namespace, let's say, in Kubernetes, is the fact that upon deployment, it has to be accompanied with component YAML. The component YAML is a custom resource definition. Kubernetes allows us to expand its API with our own custom definitions. And what this specific one includes, what it describes is, let's say, how the infrastructure should be, how it should be configured in order for our API to be exposed, meaning which path it should be exposed under, what security it should follow, scopes maybe that the JWT should contain, will it use Kafka, and stuff like this. And okay, for you, you might wonder, we have created our own CRD. Who's going to use it? I mean, Kubernetes doesn't know for sure. And this is where the C.E.L.L canvas comes into play, and everything is tied together. C.E.L.L canvas is the implementation of the ODA canvas blueprint, and it's a collection of Kubernetes operators. Now, for those who are hearing this term for the first time, Kubernetes operators are software applications, software extensions inside Kubernetes that continuously monitor the resources in the cluster. And when a change occurs, be it a new addition or a modification, depending on what we have programmed them to do, they try to bring the cluster to the desired state. For us, this is depicted in this flow where we have created a Kubernetes operator to monitor the component resource. When a change occurs there, the component resource will parse it and then deploy a set of new custom resources. And for each one of these, we have deployed another operator, Kubernetes operator, and who has the responsibility to configure a specific domain in the cluster, meaning configure the gateway and the API exposure and the authentication, configure Kafka, configure monitoring, and to be honest, the possibilities here are frankly endless. It's just your imagination and your ideas. Now, to close it, actually, since all of this is good, but it has to be depicted in numbers. This is our numbers. I mean, of course, I'm not suggesting that you or me, we're going to take 15 days to expose a gateway in Kubernetes, but for Vodafone, because it's a major telco, this process often includes external teams. External teams have their own procedures, have their own timelines, their own deadlines, and this introduces delays. Well, with C.E.L.L, we managed to cut off this delay. And now, a new gateway exposure, a new topic, a new notification channel takes 3 seconds to be configured and ready to use. And the very big benefit, I would say, is the fact that no matter your service provider, you like to use Google, Amazon, you want to create your own, the whole C.E.L.L can be deployed in more or less 15 minutes until the containerization the spin up of the containers. So this was C.E.L.L. If you have any questions, I would be glad to answer them. Otherwise, I think you found it as interesting as I do. And thank you very much.